Today I am going to solve the NCERT question, Chapter 5, Laws of Motion, number 10, and in the question number in this NCERT is 25. Figure below shows a man standing stationary with the respect to the horizontal conveyor belt that is increasing with 1 meter per second square. What is a net force on the man if the coefficient of a static friction between the man and shoes is 0.2? Okay, so first part I am going to. So what is a net force on the man? So of course net force on the man, because acceleration is given 1 meter per second square, A is given 1 meter per second square. Okay. So what is the force? So force, as we know, mass into acceleration, and mass is given, mass of this man is 65 kg. So 65 kg and acceleration is 1 meter per second square. So the force on man will be 65 Newton. So direction of this force is opposite to the direction of motion of the belt. So now the second point is, if the coefficient of a static friction between the man and the shoes belt is given 0.2, what up to what acceleration of the belt can the man continue to be stationary? Okay. So first you have to find out what is the maximum static friction force. So maximum static friction force, this will be mu into n, mu s here, mu s into m into g. So mu s is given 0.2, m is given 65, and g, suppose that if you take g equal to 9.8, so this will be, so 0.2 and 9.8, so 1.96 into 65. Okay. So in this question they are asking up to what acceleration. So now you can see this much acceleration you have maximum, because 65 is a weight, so you can write 1.96 into m, you can write. This is the maximum static force you have. So m is a mass of the person and 1.96, this is the acceleration. So the maximum acceleration, so maximum acceleration will be 1.96 meter per second square. Okay. Now the next question is in NCERT 26. A stone of mass m tied to the end of the string revolve in the vertical circle of radius r. The net force at the lowest and highest point of the circle directed, so a stone of mass, okay, start from here. A stone of mass m tied to the end of the string revolve in the vertical circle of radius r. The net force at the lowest and highest point of the circle directed vertically downward r. Okay. So let's draw the diagram first. So here I am going to draw, this is the diagram, and this is the, you have suppose that lowest position, and this is the you have highest position. Okay. At the lowest position, you know, mg will act in downward direction, tension is upward direction, and you have velocity is a v, and this is the velocity, suppose that v1. So here you can write t bottom here. So they are asking about net force at the lowest and highest point of the circle directed vertically. Okay. So at the lowest point equal to, you can write mg minus t, this equal to m v1 square by r, radius is given r. So the downward direction you have force, that is a mg minus t1, that is equal to the m v1 square by r. At the highest point, t will act here, mg will also act in the same direction. So the highest point, t plus mg force is acting, that is equal to the m v2 square by r. Suppose that velocity if you have v2. So let's, and here you have support t1, and this is you have to find t2. Okay. So the lowest point you have mg minus t1 as you have seen, and the highest point you have mg plus t2. So option A is correct. That is, so net force, someone asked what is the net force at the lowest point, you have to write mg minus t1. What is the net force at the top, t2 plus mg. Okay. Go for the next question. So a helicopter of mass 1000 kg rise with the vertical acceleration of 15 meter per second square. The crew and the passenger weight 300 kg. Give the magnitude and direction of the force on the floor by the crew and passenger. Okay. So the mass of the helicopter is given here, m1, that is a 1000 kg. Mass of the crew is given 300 kg. Acceleration of the helicopter is given 15 meter per second square, and acceleration g is given suppose 10 meter per second square. So directly you can write here. So if you suppose that, so mg will act in the downward direction, ground reaction force is n1 act in the upward direction. So you can write n1 minus mg, or this is the m2g, this equal to m2 into acceleration. So the n1 equal to m2 into g plus a, and g m2 is given here 300, and g is a 10, a is a 15, so 25 into 3, that will be the 7500 Newton in upward direction. Okay. Similarly B, the action of the rotor of the helicopter on the surrounding air. So in the surrounding air you have to go from, because net acceleration will be g plus a, so the B part equal to m1 plus m2, total mass of the helicopter plus crew member, and multiply by the net acceleration like g plus a. So this will be 32500 Newton in downward direction, and C is a force on the helicopter due to surrounding air. So the force according to Newton's third law of motion, for every action there is equal and opposite reaction. So the C will be exactly same force will act 32500 in upward direction, because this was in the downward direction, so this will force in upward direction. Okay, thank you.